Good morning, students. Today we are going to learn about direction cosines of a vector. Direction cosines of a vector say combine define ko. Let alpha, beta, gamma be the angles made by a vector OP vector with the positive direction of x-axis, y-axis, and z-axis respectively in anticlockwise direction. Then alpha, beta, gamma are called the direction angles. Direction angles of the vector and cos alpha, cos beta, cos gamma are called the direction cosines of the vector OP vector. Nangon the given vector piren khaleba. Given vector sina alpha, beta, gamma se x-axis, y-axis, z-axis ka make the angle ne na khaladi. Nangi cos alpha ki value, cos beta ki value, cos gamma ki value se kai kaurani direction cosines of a vector kawi ko. And also direction cosines can also be defined is kamina defined to way I say mong dong defined to say. The components of any unit vector which is parallel to a given vector are called the direction cosines of the vector. Nangon the given vector E am layren khaleba. Mangon the parallel or by E vector am layre ko. The components of this E vector which is parallel to the A vector are called the components of the given vector A vector sigi kai ko ba yai heba direction cosines ko ba yai ba duna direction cosines se ani thong na define to ba re mathaki sina angle the define to ko wi makhagi sina in terms of component the explain to ko wi ko then nangon the A vector am later define a unit vector which is acting along A vector. Then the components of this E kf are called kai korani direction cosines of the A vector, and direction cosines are denoted by kaina denotorani L, M, and N sina denotoy ko. Since we have magnitude of E vector is equal to magnitude of E cap is equal to 1. Nangi E cap se segi magnitude se 1 ta ni kay gino hardima se unit vector ni ko, and therefore root over component magnitude of E cap is given by root over L square plus M square plus N square. Sitare equals to 1. Then squaring on both sides, we have L square plus M square plus N square is equal to 1 tareko. Or this L, M, N are same as kay gachamane cos alpha, cos beta, cos gamma gachamane duna cos square alpha plus cos square beta plus cos square gamma will be equal to 1. Sumain taraga koina direction cosines ke rule ani phange sina in terms of component de lakadaba sina in terms of angles de lakadaba ko. Direction cosines oige hai taragadi number ahum dugi square gi sum se 1 tagadaba aduga angle da hairagana cos square alpha plus cos square beta plus cos square gamma kya tarani 1 tarani. Example, find the direction cosines of the vector A vector. Koina question si the vector ampere ko vector se ki direction cosines putu oina hang taragadi kamai hot kani first write A vector components are I cap plus 2 times of j cap plus 3 k cap. Then find A cap. A cap is the unit vector acting along this A vector, and this A cap is given by A vector divided by magnitude of A vector. First write the components of A vector I cap plus 2 times of jk plus 3 times of k divided by component of A vector are given by square root of sum of squares of its component. Have a x component, y component, and z component. Here x component is 1 square, y component is 2 square, and the z component is 3, which is equal to 3 square. Ik plus 2 times of jk plus 3k divided by root over 1 square is 1, 2 square is equal to 4, and 3 square is equal to 9. I cap divided by 9 plus 4 plus 1 is 14, 2j cap divided by root over 14, 3k cap divided by root over 14. Dunamagi components in irasiko. The direction cosines of the vector A vector are 1 divided by root over 14, 2 divided by root over 14, and 3 divided by root over 14. These are the components of the unit vector acting along a given vector A vector. So, sige se kai tarani direction cosines tarani. Next topic is section formula. Section formula da koina rule ani laiko external haiba maga internal haiba ma. First one is internal. If A vector, B vector, and C vector be the position vectors of the 2 points A and the B, then find the position vector of the point C, which divides the line segment AB internally in the ratio, current ratio the ka M is to N. Nangon the point ani pireba, point A habanga, point B habanga ka. Point AB se join the re, karamba point na ka M se C have a point sina. figure there is 2 points A and the B whose position vectors are A vector and B vector. If there is a point C which divides this line segment AB internally in the ratio m is to n. Karamba ratio the k m is to n the k ko. Then here we are going to find the position vector of this point C. Nangi point C sigi position vector puthok doine. We have position vector of A is equal to A, position vector of B is equal to B. Let this small letter C vector be the position vector of the point C, which divides the line segment AB internally in the ratio m is to n. Habdi AB gi marakta C haba point am laira AC gi length sina m oire CB gi length sina n n khale ko, and therefore this line segment AC divided by CB will be equal to m by n. By cross multiplication, n into AC is equal to m into CB. And then applying vectors on both sides. Vector hapsele AC vector is equal to m and CB vector n. Then write AC vector. AC vector means sina terminal initial point, C sina terminal point ko aduna position vector of 2 point adjoining 2 points se kamai hot kre position vector of terminal minus position vector of initial and hole ko position vector of C minus position vector of A. Then m into CB vector is position vector of B minus position vector of C. Now this OC vector is represented by small c vector and OA vector is represented by small a vector. OB vector is B and this OC vector is represented by C vector. Then multiply this C vector minus A by N. Scalar multiplication of vector niko. NC vector minus NCA. MB vector minus MCE. Here we are going to find the position vector of this point C. So transpose this MC vector from right hand side to left hand side. It should be NC square plus MC square is equal to MB vector. Transpose this minus NA vector from left hand side to right hand side. It should be plus N 2 times of A minus A plus the same story ko. NC vector plus MC vector. C common, alright? Then taking this C common from first term and second term, we have N plus MC vector equals to MB vector plus NA vector. Then find this position vector of C. Position vector of C se phange hai taragadi, we should divide both sides of the equation by kanana divide taurani. Both sides of the equation by n plus m. N plus m na divide taureko. And so position vector of C is given by mb vector plus na vector divided by m plus n. Sigi C sina a b gi manungda internally layram tardi sigi plus haina lakaniba. Aduga horan externally haiba kana this symbol se kai satkini minus ta satkini ko. Position vector kamain puthoi haiba saniyang horas. Position vector of point A is A. Position vector of this point B is B. And if there is a point C which divides this AB internally in the ratio m is to n, then this position vector of C is given by this m should be multiplied by position vector of B. And this n should be multiplied by position vector of A. If C is inside of AB, then this sum will be plus mb vector plus na vector divided by m plus n plus 1 ilakani ko. So nangi internal formula lere ko. Corollary: if C is the midpoint of AB, then C divides the line segment AB in the ratio 1:1 and the position vector of midpoint. The position vector of the midpoint C of the line segment AB is given by kaigi formula na pigani B vector plus A vector divided by 1 plus 1. 1 plus 1 is equal to plus 2. Here m की value से 1 tagani, n की value से क्या tagani 1 tani ko, or it can also be expressed as a vector plus b vector divided by 2. Nanga sagi sigi point C sa sina midpoint oram taragadi nanga AB se karamba ratio da kakani. If C is the midpoint of the line segment AB, then this point C divides AB in the ratio 1:1. Putting the value of m is equal to 1 and n is equal to 1 in this expression, we have the position vector of C is represented by A vector plus B vector divided by 2, means position vector of point A plus position vector of point B divided by 2. Sigi formula na P niba. Now on the point ani P sigi position vector se plus tauro makhada kay na divide taurani 2 na ko. Sinakaram kande apply taugani if C is the midpoint of kanagi midpoint or kanda given 2 points to give midpoint or kanda. Next rule is external formula. If A vector, B vector be the position vectors of the 2 points A and the B. Then find the position vector of the point C, which divides AB externally in the ratio. Karamba ratio da ka M is to N ko. Nangi ngasagi C sina internally haiba kanana internally gi rule lare ko. Handak na externally gi apply to tare. Sida point ani pira. There are 2 points A and the B whose position vectors are A vector and B vector. And if there is a point C which divides this line segment AB externally. Externally means C se AB gi manungda lairaroi ko mapanda laidoin. Aduga A dagina C bausina M taraba. C dagina B bausina N tare ko. The karamba ratio da ka A hang taragadi AC divided by BC is equal to M divided by N. Here we are going to find the position vector of this point C. In this case, we have position vector of point A vector, position vector of the point B is equal to B vector. Let C vector be the position vector of the point C, which divides the line segment AB externally in the ratio. Current ratio the Ka, M is to N the Ka ko. And therefore, AC divided by CB is equal to M divided by N. By cross multiplication, N into AC is equal to M into BC. Then apply vector on both sides. Vector half equal N into AC vector is equal to M into BC vector. Then this AC vector is represented by OC vector minus OA is equal to M into OC vector minus OB. OC vector is represented by C vector. OA vector is represented by A. OC vector is C vector. OB vector is represented by B vector. Then multiply this expression by N and the M. We have this equation. Transpose this MC vector from right hand side to left hand side. The C yauriba terms right side tagi left transpose taurasiko. Koina hojik C gi position vector puthoktoinina. N times of C vector minus MC vector is equal to transpose this minus A vector from left hand side to right hand side. It should be N A vector minus MB vector. C common loreko. We have N minus M is equal to N A vector minus MB vector. Then find the position vector of C. Dividing both sides by kaina divide tauthooga N minus M na divide tauthooga. N A vector minus M B vector by N minus M. Or it can also be expressed as M B vector minus N A vector divided by M minus N. Masagi internally haibado. Internally haiba kanana the formula se plus oin laineba. The externally hara kanana formula se kaina lakani minus oin lakani ko. Sumaina internally ga externally ga gi tongan ba formula laire. Now let's come to exercise 10.2. Exercise 10.2 gi question number 13 the last ko. Find the direction cosines of the vector joining the points point A and point B. Coordinates of point A 1, 2, minus 3 and coordinates of point B minus 2, minus 1 and plus 1. Directed from point A to B. Nangi direction sa A dagi kadom na chatkani B da chatkadamni ko. Exercise 10.2 question number 13 we have the coordinates of A 1, 2, minus 3. Coordinates of B minus 1, minus 2 and plus 1. Then write AB vector. AB vector is given by position vector of B minus position vector of A. AB vector se kaina pigani position vector of B minus position vector of A na pireko. Then write the components form of OB vector. Minus 1 multiplied by I cap, minus 2 multiplied by J cap and 1 multiplied by K minus. OA vector component form of OA vector is I cap plus 2J cap plus minus 3K cap. X, Y, Z components X dana I na, Y dana J na, Z dana K na multiply togani ko. Then subtract these two vectors. Kuna vector anisa in terms of component the subtract toge haitaragadi find the difference of corresponding component. Minus 1, minus 1, minus 2 I cap, minus 2 plus minus minus, minus 4 J cap, plus 1 minus minus plus and 3 plus 1 is equal to 4 tareko. So minus nangi A, B vector se ire. Hauze hangiba question na kaino. Here we are going to find the direction cosines of the AB vector. Direction cosines means the components of any unit vector acting along the given vector A a vector haiba vector amada ek tauba nangi unit vector amagi component sing sineba mana direction cosines haise ko aduna a b cap uthose ko a b cap means a unit vector acting along this a b vector. By formula, this a b cap is given by a b vector divided by the magnitude of AB, which is equal to minus 2I cap minus 4j cap plus 4 times of k cap divided by magnitude of AB vector is equal to root over x component square minus 2 square plus minus 4 whole square is 16 and 4 square is equal to 16 minus 2I cap minus 4j cap plus 4k cap divided by 4, 16 and 26 हमसे क्या गमाना है 36 तारेगा 36 is the square root of 16 so minus 2I cap divided by 6 minus 4j cap divided by 6 plus 4k cap divided by 6 2 3 1 by 3 I cap 2 3 2 by 3 तारेगा and 260 2 3 k cap minus 1 by 3 minus 2 by 3 and plus 2 by 3 are the components of this AB cap and therefore direction cosines of the AB vector are minus 1 by 3 minus 2 by 3 and 2 by 3 direction cosines horeको. Next question number 13 से मैं यहाँ से find the position vector of the point R which divides the line joining the 2 points P and Q whose position vectors are I cap plus 2j cap minus k cap and minus I cap plus j cap plus k cap respectively in the ratio 2:1. Find internally and externally. Nang step P is ahanbagi sina internally the k ani subasina kay the k externally the point P haibamga Q haibamga hojik laire ko aduna point R sina bisect tawre se karamba ratio the bisect tawi 2:1 the bisect taw have say yang say there are 2 points P and the Q and point R which this point R divides this line segment PQ internally or externally in the ratio 2:1. Then here we are going to find the position vector of this point R. Since R divides PQ internally in the ratio 2:1 and so OR vector will be equal to nangi OR vector sa kaigamanani this OR vector is equal to 1 dot OP vector plus 2 dot OQ vector. Position vector of PD IK plus 2JK minus KK. Position vector of Q na minus IK plus JK plus KK pireko. And therefore this OR vector is equal to 1 multiplied by OP vector and 2 multiplied by OQ vector. Sige maga nakna basina taba kare lapthok basina multiply tauneba 2 na position vector of Q the 1 sina position vector of P the multiply taurani ko 1 dot OP vector plus 2 dot OQ vector divided by 1 plus 2 ratio ni ko sige mong de ithoe position vector of P IK plus 2 times of J minus K and position vector of Q is minus IK plus JK plus KK and 1 plus 2 IK plus 2JK minus KK. Then multiply these vectors by these components by 2 minus 2I cap plus 2j cap plus 2k cap divided by 3 and find the sum of corresponding component plus 1 minus 2 is equal to minus 1 I cap by 3 plus 2 and plus 2 is equal to 4j cap by 3 minus 1 plus 2 is equal to k cap divided by 3 and this is the position vector of the point R. Nangi point R the position vector oidiniko. Roman number 2. Since this R divides the PQ externally in the ratio 2:1 externally oitaradi plus sign do kay set krani minus sign tarani ko and so position vector of OR vector is given by 1 dot OQ vector minus 2 dot OQ vector divided by 1 minus 2 and so write the position vector of OP IK plus 2 times of J minus K minus 2 then write the components of OQ minus IK plus JK plus KK divided by 1 minus 2 is equal to minus 1 IK plus 2 times of JK minus K then multiply these components by minus 2 minus minus plus minus plus minus and minus plus minus tareko. Then find the difference of corresponding component plus 1 plus 2 3 I cap plus 2 j cap minus 2 j cap is equal to 0 j cap minus k minus 2 cap is equal to minus 3 k cap 3 I cap divided by minus 1 is minus 3 0 divided by minus 1 is 0 j cap and Minus 3 divided by minus 1 is minus minus plus. And so this is the position vector of the point R, which divides the given 2 points PQ externally in the ratio 2:1. For today, let's end here.